This conversation is powered by Google Illuminate. Check out illuminate.google.com for more.
Today's discussion centers around an intriguing interactive physics simulation, Buoyancy level JavaScript simulation, Applet HTML5. It's designed to help students grasp a fundamental concept, but with a clever twist.
The twist lies in presenting a seemingly simple problem in a way that forces students to think critically before resorting to experimentation. It's all about prediction and then verification.
Exactly. The simulation poses a question about the change in water level when an object is placed inside a floating container versus when it's suspended beneath it. What's the key takeaway here?
The key is understanding the interplay between buoyancy, fluid displacement, and the resulting pressure changes. It's a visual demonstration of Archimedes' principle.
And it's all done through an interactive applet, easily embeddable in websites. Let's dive into the details. Let's start with the core concept, buoyancy and displacement. How does the simulation illustrate Archimedes' principle? The simulation visually demonstrates that the buoyant force on an object is equal to the weight of the floor it displaced. By observing the change in water level, h and h, students can directly see the relationship between the object's weight and the volume of water it displaces, regardless of whether it's inside or hanging below the container.
The simulation strongly emphasizes prediction before experimentation. Why is this approach so valuable?
It fosters critical thinking. By forcing students to formulate a hypothesis before interacting with the simulation, they actively engage with the underlying physics principles. It's not just about observing, it's about predicting and then testing those predictions.
The applet's interactive nature is a key strength. How does interactivity enhance learning?
Interactivity allows for active learning. Students can manipulate variables like liquid and object density, observe the immediate effects, and gain a deeper understanding through direct experimentation. The HTML5 and JavaScript design ensures accessibility across various platforms.
This simulation is part of the Open Educational Resources/Open Source Physics at Singapore project. What does that mean for accessibility and broader impact?
It means the resource is freely available, promoting wider access to quality educational materials. The use of AI tools in its development highlights the potential of AI in creating innovative and engaging educational resources.
The central question posed by the simulation of the relationship between H and H is quite insightful. Can you elaborate on the significance of this comparison?
The comparison directly addresses the core concept of buoyancy and how it changes based on the object's position relative to the container. The interactive elements, such as sliders for density and draggable labels, further enhance the learning experience by allowing for customized exploration.
Who is the intended audience for the simulation?
Primarily physics students learning about buoyancy and Archimedes' principle. However, its accessibility and engaging nature make it suitable for teachers and anyone interested in exploring physics concepts interactively. The extensive related resources on the Open Educational Resources website further broaden its potential use.
The accompanying study guide provides a comprehensive framework for learning. How does it support the simulation's educational goals?
The study guide interforces the concepts introduced in the simulation through quizzes, essay questions, and a glossary of key terms. It provides a structured approach to learning, ensuring students grasp the fundamental principles and can apply them to different contexts. The sample learning goals clearly define what students should achieve after using the simulation.
The FAQ section addresses common questions about the simulation's purpose, functionality, and accessibility. What are some of the key points highlighted in the FAQ?
The FAQ clarifies the simulation's purpose, its creators, its interactive features, and its embeddability. It also emphasizes the open source nature of the simulation and its licensing.
The website lists many other simulations. What does this breadth of resources suggest about the project's overall goals?
The wide range of simulations demonstrates a commitment to providing comprehensive and diverse educational resources across various physics topics. It showcases the potential of open educational resources in supporting a holistic learning experience.
The licensing information mentions EasyJavaScriptSimulations. Can you clarify the licensing for commercial use?
The simulation itself is open source under a Creative Commons license. However, the EasyJavaScriptSimulations library used to build it has a separate license for commercial use, requiring contact with the library's developers.
What are some potential limitations of the simulation, and how could it be improved?
While the simulation effectively demonstrates core principles, it might be simplified compared to real-world scenarios. Future improvements could include more complex fluid dynamics, the ability to incorporate different object shapes, and perhaps even more advanced analysis tools.
So in essence, this buoyancy-level JavaScript simulation applet HTML5 is a valuable tool for teaching and learning about buoyancy, offering an interactive and engaging approach to a fundamental physics concept.
Absolutely. Its focus on prediction, combined with its interactive elements and open source nature, makes it a powerful resource for educators and students alike.
That was a great discussion. Thank you.